Well, I hope you didn't think that last riddle was a little bit too corny for you, but here's another one. What 7-letter word becomes longer when the third letter is removed? What 7-letter word becomes longer when the third letter is removed? Pause the video if you want to think about it. And the answer is the word lounger. The third letter is removed, it becomes longer. I'll let you think about that. So our next two equations here that we want to graph, next two functions are exponential functions. And just like we did in the log graphs, I want to just give you a little bit more intuitive approach to graphing these exponential functions. And actually, I don't really like this as much as I like the transformations. I do like the intuitive approach to the logs more than I like that method with the exponentials. But nevertheless, you can gain a little bit of insight maybe and help yourself a little bit understand how to graph these functions a little bit better. So the key point, if you remember on the exponential functions, no matter what the base is, when that variable, when that exponent is 0, we get any number to that 0 power is just 1. So y then is just whatever's left over when you replace this exponential expression with 1. So when x is 0, y is 1, and we get 0, 1. No matter what the base is, raised to the 0 power is going to go through the point 0, 1. And then the horizontal asymptote, this is something I don't think I've even mentioned, but notice that there's nothing added here. Okay? And remember, when things do get added or subtracted from the function itself, we're going to adjust the graph of the original function up or down. Well, the original function has 2 to the x plus 0, and since we don't adjust this function up or down, y equals that number right there is always going to be our horizontal asymptote. And so y equals 0 is a horizontal asymptote. And remember also, I can't remember who said it, but the horizontal asymptote and the key point, both for logs and exponentials, are always 1 unit apart. And then you can plot some points here. You can pick some convenient values for x. You can see a pattern. When x is 1, y is 2. When x is 2, y is 4. When x is negative 1, y is 1/2. Okay, 2 to the negative 1, 1/2. So you just plot some points and you can see the general shape, and you should remember what the general shape is anyway. And let's see how that works over here. Okay, 4 minus e to the x minus 1. Well, our key point, remember, is whatever makes the exponent equal to 0. Okay, well, what makes the exponent equal to 0? Well, that's x equals 1. Alright, when x equals 1, what does y equal? Y equals 4 minus e to the 0. 4 minus 1, which is 3. So our key point is at x equals 1, y equals 1, 2, 3. So this gets a little bit harder to remember. You know, how would you remember to make the exponent equal to 0? I don't know. How do you remember to do the transformations? So choose your poison. Decide which you would rather remember and work it that way. The vertical, oh, did I write vertical asymptote there? That was dumb. Sorry. That should say HA. Always a horizontal asymptote. Probably worthwhile to go ahead and throw that in there now. You know that exponentials, remember, well, our mnemonic device there is the exponentials, right? Have that long E, reminding you that there will always be a horizontal asymptote. Okay. And let's see. The horizontal asymptote for exponentials is just that number right there. Y equals that number. Okay? That's it. Y equals that number. I know you're probably hoping for more, but that's it. Y equals 4. So y equals 4 there. And I like to draw my horizontal asymptotes in red. So we have y equals 4. Now we know that our graph goes below that, and we could either find an x-intercept or a y-intercept. Again, our two options. That asymptote is there for a reason, guys. Okay, it's going to be a guide for our graph. So our graph's going to look like this. I'm not super concerned that you know exactly where these go through the x-axis or even the x-axis or the y-axis. just want you to get the general shape. So it's one of these. And so what do you want to do? You want to get a y-intercept, so maybe we do that. Okay, so we're going to pick a convenient value for x. And if we pick, let's say 0, so we're going to look for the y-intercept. So you're going to be down here less than 3, or it's going to be between 3 and 4. Okay, so we get 4 minus, that's e to the negative 1. Alright, well, e to the negative 1 is 1 over e. And at this point, what I recommend is replacing e with 3. Okay, oops, you can't even see what I'm doing, sorry. So we have 4 minus e to the negative 1 when x is 0. 4 minus 1 over e, 4 minus 1/3. So it's about equal to 4 minus 1/3, which is 3 2/3. Well, 3 2/3 is clearly this one right here, and so therefore we have our graph. That's what we do. I'm looking for my green. There we go. So clearly, 4 minus something like 1/3, that wasn't that bad, is definitely between 3 and 4, and so that graph right there would represent the graph of our function. Our key point being at 1, 3. Okay, that was 6 minutes. So let me see if I can squeeze this last one in here. Now this one's a bit trickier. Let's at least get our key point. Now we know, again, our key point is when our exponent happens to be 0. Okay, so when this guy right here is 0, which would be when x is equal to 4. You hear my pens. So when x equals 4, we get 3 to the 0, and that's 1. So that means y equals 2 plus 1, or 3. So we get the point 1, 2, 3, 4, 2, 3. Something tells me I'm doing this wrong. Okay, well, we'll see. And then our horizontal asymptote, remember, is always just that number right there, because we've moved our original graph up 2 units. So if we move our original graph up 2 units, go up here, 1, 2. So that gives us a good idea of what's going on. So that's y equals 2. And now, since you can hopefully tell that there will be no x-intercept, and so we need to find our y-intercept. So let's take a look. So it's again either going to be, this is probably the easiest way to do it. It's either going to be like that. So the y-intercept is either between 2 and 3, or it's way up there somewhere. It's going to be a really, really big number. Okay? And you should be able to tell the difference. So let's choose that. Let's choose x equals 0. And when x equals 0, we get 2 plus 3 to the 4th power. Okay, well, obviously that's not between 2 and 3. 3 to the 4th power is 81, and 81 and 2 is 83, so yeah, it's going to be a really big number. So let's just draw the graph like this. So you know it's going to come down like that. I hope that helps. I really do. I know it's frustrating when it seems like you've tried everything, but maybe you haven't. Try to dig a little deeper now if you've been having trouble with these log and exponential graphs, and you just might surprise yourself. And it sure is a lot more fun when you're getting them right. I know that. Have a great night, and I will talk to you soon. Hopefully, well, let's see. I got room for one more riddle here. Here we go. If you can speak properly, you will be able to answer the following question. Which is correct? The yolk of an egg is white, or the yolk of an egg are white? Pause the video if you want to think about it. And the answer is the yolk of the egg is yellow, not white.